All right, everybody, I'm going to make it through 7-3 now, and then I'm going to get myself a cup of tea. So that must mean I am ready to be done. And I bet maybe, well, hopefully not at the beginning of the notes that you're ready to be done. Anyway, today we're going to talk about more multiplication properties of exponents because you know what? We haven't had enough fun with the ones we've done so far. So we're going to kind of take some ideas and go a little further with them. So we are going to do raising a power to a power. What you're going to notice today is that the base is not written twice. The base, like A, is only written once. So what do we do if there's parentheses and then two exponents? So glad that you're asking. You're going to end up multiplying those, okay? So let's apply that to a number. So let's say we have 5, a base, and we have it to the exponent of 4, and again to another exponent of 2. So you multiply them, 2 times 4 makes 8. And sure enough, they didn't put it in their calculators. The book here, let's see, it would have been 390,625 if you would have fully evaluated it. So 390,625 if you would have fully evaluated it. Say hi to Miss Bodner.
Hi. Math is fun.
Math is fine. And now if we want to do that with a variable, so let's say we have a base of a, and again, these are exponents being raised to an exponent, you would multiply these. Now, on the keystones, you are not going to have fractional exponents. They'll be normal exponents like 2, 3, 4, -1. Long story short, you multiply them and you take that base to that power. Variables can't go in the calculator. Please don't try. All right. So I gave you a detailed example, and I thought, okay, let's just talk it through and then we'll work a few out. We'll start easy, do difficult, but we're going to start with a big old example. Let's say that we are given, let's get rid of this calculator, okay? Let's say that we're given this particular expression. Okay, so we have two separate items here. Like the first item is here, the second item is here, and they're going to be multiplied together. But we have that outside 3 and we have that outside 2 to worry about. So we need to distribute the exponents from the outside into the parentheses. So take a look at this. Let me erase all that crazy stuff. This 6 has a 1, this 5 has a 1. All right, so this 3 goes to this 1, the 3 goes to this 4. Oh, and the B has a 1, and this 3 goes to the 1. This 2 goes to the 1, this 2 goes to the -3, and look, that gets done by multiplying them because you're raising a power to a power. The next thing we're going to look at is multiplying the exponents together. So you distribute it, and now it's time to multiply. Well, 1 times 3 is 3, 4 times 3 is 12, 1 times 3 is 3, 1 times 2 is 2, -3 times 2 is -6. Let's go see what we do next. Simplify the coefficients and get all the like bases put in order. All right, so I have, ooh, look at this. So I will highlight 6 to the third is 216. 5 to the second coefficient is 25. And then I have a, let's see if I can color code those. I have a to the 12th and a to the -6. See how I wrote those? We learned that in the last section. You add those ones. And one more color here. You ready? B to the 3, and that's the only one, so just B to the 3 in the back. The last step we're going to do, let's scroll on over. Bum, 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 bum. Multiply the coefficients and add the exponents from the step above. So multiply the coefficients. So that would be orange times pink makes 5,400. Add the exponents from the step above to make +6. And then that b to the third had nothing going on to it, so it just traveled down. All right, well, it's my job to make that look easy, and hopefully I did. It's also my job to hopefully make it easy for you. So let's try that together. How many examples? I got 9 examples here. They get increasingly difficult, and then a few down below. So let's see what we need to do. All right, here we go. We have 3n to the -6. That's the inside stuff. So I'm going to, because I love colors, I'm going to do orange, I'm going to do blue, and then I'm going to grab a black pen. I'm going to put a 1 on this 3 because he doesn't have an exponent. I'm going to take this -4, put it like that because it's a power to a power, and take this and put it like that. So I will have 3 to the first times the outside -4, n to the -6 times the outside -4. There's where the blue, that's what happens to the blue. That's what happens to the orange. Next, I need to do multiply those. So 1 times -4 makes -4. -6 times -4 makes +24. And, ooh, I need to remember to take care of this. Remember how we used to write the word move? So I'm going to move it to the bottom, keep this on the top because it was positive, and then I'm going to type this one in my calculator because it's a number, it's not a variable. So n to the 24 stays put. 3 to the 4th in my calculator would be 81. I should grab that calculator because I know I'm a visual person, so seeing it typed out would be very beneficial for me as a student. So here's 3 to the 4th, so you can see where I got 81 from. All right, next. So I am going to color code. I have my 5 to the first power. I have my y to the second power. And I'm going to take this outside 4 like that and like that because I'm raising a power to a power. So that's 5 to the 1 dot 4, 1 times 4, y to the 2 dot 4, 2 times 4. There's the blue. That's what happened to the blue. There's the orange. That's what happened to the orange. Multiply your exponents and rewrite. So 5 to the 4, y to the 8. There is nothing that needs to move. The only thing that needs to happen is I need to type whatever I can on the calculator. So 5 to the 4th, I will color code that as my orange, becomes 625. Okay, that's what I did. I just typed my numbers on my calculator. And then y to the 8th just chills out in the back. And that's your final answer. All right, we're going to start applying rules from yesterday now as well, or 7-2, where we add our exponents. Here we go. This is going to be 2 to the first. Make sure you do that, please. All right, I'm going to have a orange and I'm going to have a blue. Oh, and there's another blue because they're both bases of x. So this 3 goes here, this 3 goes here, but it does not go to that 2 because it's not part of the parentheses. So this will be 2 to the 1 dot 3. I'm distributing in my outside 3. X to the 6 dot 3. I'm up distributing in my outside 3. And then that x to the 2 travels down. If you like the colors, there's the first blue, there's the second blue, and here was the original orange. This becomes, we're going to multiply our exponents, 2 to the third, x to the 18, and x to the second. Now I need to apply a couple of rules. Nothing needs moved because nothing is negative. However, I need to put this on my calculator, and 2 to the third becomes an 8. So you can see the orange just kind of traveling down, becomes a pretty 8. And then please remember from yesterday, I would need to take, see how these are common bases? I need to do 18 plus 2. I add my exponents when my bases are written twice for a final answer of x to the 20th. So you can see how the blue kind of comes down, and you have to remember when it's written twice, if it's written twice, to add them. Okay, here we go. I'm going to put a 1 on my S before I do anything else. And just so this doesn't get in the way, I am going to shrink this down so I can keep this in its picture by itself. All right, so it looks like I'm going to have an R to the 5th, and it looks like I'm going to have an S. So this 5 goes to this 5 goes to this 1. R to the 5 times 5, S to the 1 times 5. Multiply R to the 25, multiply S to the 5th. Nothing's negative, nothing moves, and nothing can get put in my calculator. Next, so this one we are definitely upping the ante here, okay? So what we're going to do is we're going to highlight orange, that's a base of 3. Highlight B, it's a base of B. Oop, there's another base of B. And maybe in green, I have a base of A. All right, so I have 3 bases. I have a 3, a B, and an A. This 3 needs a 1. Please don't forget about that. So this outside 2 goes here and here. I'm going to do that first. 3 to the 1 times 2, B to the negative 2 times 2. And now I'm going to take this and go here and here. I didn't need any missing ones. A to the 2 times 3, B to the 4 times 3. I will tell you right now, kids who skip this step get confused and they simply get it wrong. Don't be one of those kids. Don't skip that step. Okay, so now I'm going to multiply my exponents. So this is 3 to the positive 2, b to the negative 4, a to the positive 6, and b to the positive 12. That looks good, but it's not done yet. Remember yesterday, and I'm going to color these, okay? So I have my A's were green, my B's were blue, and FYI, I don't color these for myself. I color these because it makes it easier. So if you're thinking, oh, I've got this in the back, just put some colors on them. It's going to take you 2 seconds and it's going to really help. So 3 to the second is a 9. You can type that on your calculator. Anything that's all numbers can go in your calculator. Now, I need this b to the negative 4 to add to the 12. So these have to add together. And then my a to the 6 is just chilling down below. Final answer is the 9. B will have a positive 8 when you add these, and A will have a positive 6. While that is a really nice answer and totally acceptable by me, the keystones will put it in order. They'll have the coefficient, then the A, and then the B. All right, looks like we have some missing boxes here, trying to figure out what goes in those. Those directions, and I'll fix that. These directions should have been inserted right there. Before I post the notes, I will fix that on your end. So what goes in this box to make this equation true? Well, remember, whatever these are will be multiplied. So I'm saying the box times 3 has to make negative 12. Well, inverse property would tell me to divide. The box needs to be a negative 4 because negative 4 times 3 is the only thing that will give you negative 12. Let's see what this box is going to be. So remember, there's a 1 hiding here. So the 9 times the box has to equal this 1 because they were both the exponents of n. Okay, they're the common base of n. So 9 times what equals 1? Oh, this is icky, and I apologize for this. Dividing that out, if you did 1 divided by 9, you'll get 1/9, and that's my bad. I won't test you on anything like that. I told you there's no fractional exponents on the keystone, so that would usually just be a regular old number. All right, now this one. So I have the 7 just chilling in the front. He's just chilling. He doesn't actually affect our problem. But this 1 times the box has to make that 10. So the 1 times the box has to make the 10. So let me think. 1 times what equals 10? Well, let's do some division. Divide each side by 1. 10 is what would have to go in the box because 1 times 10 would give you that 10. Let's do the same thing again. What would go in this box so that when you do the box times 6, you end up with 12? Well, if you would divide each side by 6, you would know that inside the box would have to be 2 because 2 times 6 is what gives you 12. This one, I've already done. That's interesting that I did it twice. That was cute of me. So I'm just going to like do an X over that. I'll fix it on yours. In your examples, please find this one. Sorry, my original was kind of wonky. Yours should be all fixed up though. So I need to really think this one through. I'm actually going to just look at this part and I'm going to give the 3 a 1 like that, okay? So this 3 is going to have to come here and it will be 3 to the 1 times 3. This 3 is going to have to come here, x to the 3 dot 3. And this y has a box times the 3. And that's going to need to end up with 27x to the 9th. That's odd. Well, if you can see here, this is 3 to the 3rd. This is x to the 9th when you multiply. So when you're wondering where did they get that 27, that came from 3 to the 3rd. Type it in your calculator if you're not certain, if you don't believe me. And the x to the 9th is from the 3 times 3. But did you notice that the y is gone? So I need to know if the y is gone, then that's because its exponent would have been 0, right? In order for the y to be gone, its exponent would have to be 0. So what times 3 would have to be 0 so that the y would be gone. Well, if you divide each side by 3, you would notice the only thing that could be in that box to make a 0 is a 0. So the box would have to be 0. And how did I do? I feel like I've already done one very similar to this, so I will also take this one off. All right, that's it. I'm going to fix up your notes so they're in the right spot. I apologize for that, but just make sure you find the right one when you do these notes. And I'll check you out later.